They are the darkest objects in the universe, yet they shine the brightest light on how the cosmos truly works. Black holes. Regions of space so dense, so powerful, that nothing can escape their grasp. Not light, not time, not even the laws of physics as we know them. For decades, scientists believed black holes were simply the ultimate destroyers, cosmic vacuums that swallow everything that dares to come close. But now, we're beginning to ask a much deeper question. What if black holes aren't the end of everything, but the beginning of something far greater? To understand that, we have to go back to where a black hole begins, with the death of a star. When a massive star runs out of fuel, its core collapses under its own gravity. The pressure becomes so intense that the atoms themselves are crushed together, and the star's outer layers explode outward in a supernova. What remains, if the core is heavy enough, is a singularity, a single point where all the mass of the star is squeezed into infinite density. Around it forms an invisible boundary called the event horizon, the point of no return. Once anything crosses it, no signal, no particle, not even light can escape. To the outside world, it's as if whatever entered simply vanished. But inside that darkness, reality itself begins to bend. According to Einstein's theory of general relativity, mass warps spacetime, and black holes are the ultimate warpers. They don't just bend space, they twist the very fabric of time. To an outside observer, anything falling toward a black hole slows down, appearing to freeze in time as it approaches the event horizon. But for the object itself, time flows normally, and within seconds, it plunges into the unknown. So what happens next? For years, that question haunted physicists. Einstein's equations predict that at the singularity, the curvature of spacetime becomes infinite, meaning the laws of physics break down. It's the one place in the universe where our understanding stops working. Stephen Hawking once called it the edge of physics. But even he suspected it might not be an end at all. Perhaps, in a strange way, it's a doorway. Here's where the story gets wild. When we say black holes destroy everything, that's not entirely true. According to the law of conservation of information, information about every particle that falls into a black hole can't simply disappear from the universe. Hawking proposed that black holes slowly emit energy over time, a process known as Hawking radiation. Eventually, that radiation would cause a black hole to shrink and evaporate. But if it disappears completely, where does the information go? Quantum mechanics tells us that information cannot be destroyed. So perhaps instead of dying, black holes transform it. Some physicists think the information gets imprinted on the surface of the event horizon, like a cosmic hologram. Everything that falls in isn't lost, just encoded in another form, waiting to be released back into the universe. Others suggest something even more extraordinary, that black holes might be gateways, bridges to other regions of spacetime, or even entirely new universes. If a black hole collapses matter into an infinitely small point, what if that point then expands on the other side, creating a white hole, the opposite of a black hole, where nothing can enter but only escape? It's a theoretical mirror, and some cosmologists believe our universe itself may have been born from such a white hole long ago. In that sense, every black hole could be a seed of creation. Every galaxy, every star, every atom might trace its ancestry to a single collapse that happened in a parent universe. A cosmic cycle of death and rebirth, black holes consuming one world to give birth to another. It's an idea both terrifying and beautiful. The ultimate destruction, becoming the source of new beginnings. But how can something that traps even light be linked to creation? To answer that, we must look deeper into their geometry. Mathematically, a black hole doesn't have a center in the ordinary sense. Its singularity is not a physical point in space. It's a region where dimensions themselves collapse. And where dimensions collapse, new ones can emerge. Some theories of quantum gravity propose that inside every black hole lies a wormhole, a tunnel through space-time itself. The mouth of that wormhole would be the black hole's event horizon, and the other end might open into another universe. A universe with its own laws, its own physics, perhaps even its own notion of time. Of course, we can't test this yet. Anything crossing the event horizon is cut off from us forever. Even if someone could fall inside, they'd be stretched, crushed, and compressed in a process scientists poetically call spaghettification. But for them, time might flow differently. They might experience the entire future of the universe before being destroyed or reborn as something else. And yet, black holes do communicate with us. Not with light, but with gravity. In 2015, the LIGO Observatory detected gravitational waves, ripples in spacetime caused by two black holes colliding. The signal came from more than 1 billion light-years away, and it confirmed Einstein's century-old prediction. But it also gave us something profound, a way to hear black holes speaking. Those waves are the echo of creation itself, two cosmic giants merging into one, bending reality so deeply that space vibrates. Then in 2019, we finally saw one. The Event Horizon Telescope captured the first ever image of a black hole in the galaxy M87, 55 million light-years away. That glowing ring, a shadow surrounded by light, wasn't just the picture. It was proof that black holes are real. The shadow showed us the boundary between being and nothingness, a visual reminder that even in absolute darkness, there is structure, beauty, and meaning. And yet, the biggest mystery remains unsolved. What truly happens beyond the event horizon? Is it chaos, order, or something beyond either? Does time stop or start over? When matter is crushed into infinity, does it end or does it reboot reality from within? Some physicists believe black holes are the universe's way of recycling energy and information. Others believe they are portals to the multiverse. And some go further, suggesting that the entire universe we live in might exist inside a massive black hole. Think about it. Our universe began with the Big Bang, an explosion from a single infinitely dense point. That sounds a lot like a singularity, the heart of a black hole. Maybe the Big Bang wasn't the birth of everything, but the other side of something else collapsing. If that's true, then every black hole in our universe might be giving birth to another universe, a cosmic family tree stretching across infinity. Each new universe born from the ashes of another, each carrying the physics of its parent, but with its own variations. In this grand design, destruction and creation are not opposites. They're the same act, seen from different sides. So perhaps the truth about black holes is that they are not monsters of chaos, but architects of order. Not endings, but transitions. Every black hole could be a womb for a universe yet to come. And every time a star dies, the cosmos might be writing a new beginning in its darkness. We may never cross an event horizon. We may never see what's inside. But in a way, that mystery is the point. Black holes remind us that knowledge has limits, and that wonder begins where certainty ends. They are the ultimate paradoxes, voids that define existence, darkness that reveals light, and endings that may, in truth, be beginnings. So the next time you look up at the night sky, remember, somewhere out there, in the silent heart of a galaxy far away, a star is collapsing, space is curving, and a new universe may already be forming. Don't forget to like, share, and subscribe to WiseUse, because sometimes to find where the universe begins, you have to look into where it ends.